Hello everyone, this is Aditya, and today we are going to understand the basic concepts of NLM, that is Newton's laws of motion, and it will include both rotation and friction also. So get ready for the lecture, and of course this lecture won't be that much long because I will cover basic problems in this, not too high level problems, because this video is for just building your concepts, and you all know that I don't make videos for JEE or NEET or any other competitive exam. I teach for bachelors and masters. So I'm making this video because many requested me on this topic, so I'm making the video on Newton's laws of motion. And of course, if you all want some advanced questions also on this topic, I'll make that also. But first of all, let's try to build up some concept on it, right? So that we can move to advanced problems also, right? So let's start with the video. But before that, please do like, share, subscribe my channel, and please support this video. Now let's start with the lecture. So let's start with first kind of problems which you see in your examinations, right? So this is an inclined surface and a mass is placed on that surface. So now there are two cases in this case. The first one in which friction is not involved, and the second case in which friction is involved. So first of all, let's understand it without friction, because many just wrote learn the formula that the acceleration will be g sine theta, and then they don't even worry about its derivation. But suppose if I remove theta from here and I write theta over here, then in that case also will the acceleration will g sine theta? Of course not. It will then become g cos theta. So that is why it is very important to learn derivations also. Of course, for the purpose of exam, you can learn formulae, but the most important thing is that you should know how to apply those formulae, right? So that is why derivation is important. So before learning any concept or while learning any concept, basically, you should derive each and every point of that problem or that concept, so that you never forget that concept. And even if something is like changed in that problem, then also you can easily solve that problem, right? That problem or similar kind of problems. And in fact, if you know the derivations, then you can easily solve any level problems, right? It depends on you, right? That how much you practice and how much you are conceptually clear, right? And conceptual clarity only comes when you derive things and try to relate it to your life, right? Because physics is not a subject, it is a part of your life. It is actually your life, because everything you do in your life is just physics, right? You're walking, in that also physics is involved, because while walking friction is involved. If friction is not there, you can't move, right? So in each and everything of your life, every smallest thing, physics is always involved. So that is why don't take physics as a subject, take it as a part of your life. So why to get bored with physics, right? Okay, so let's come back to our problem. So first of all, let's assume. So now just imagine you have an inclined surface and you kept a block over here, and you assume that there's no friction on that surface. So of course the block will slide down, right? With a constant acceleration. Why? Because there's no other force involved in that except gravitation force, right? Now the gravitation force will always be acting on the block and on this surface, on this inclined surface also, but we are not worrying about that, because that is irrelevant right now. Okay, so this is our whole system and we are working on this mass, right? So let's calculate its acceleration. So suppose its mass is m, right? Now notice that the gravitational force acts downwards, right? Now the gravitational force acts toward the core or the center of the earth, right? But since we are dealing on the surface of earth, and since earth is very large as compared to this object, this system, so we assume that this force is perpendicular to the surface, right? Fine, correct? Okay, so basically we don't need to worry about this, but it is a good practice to understand that this will be perpendicular to the surface, right? So it will make calculations easy for you, right? So basically this is mg that is acting on the body. Now let's break its components, right? So let's draw a perpendicular on this surface, right? Like this. So we have one perpendicular over here and one perpendicular over here, but don't worry about this one. Okay, fine. Now let's see what will be this angle. Do you know? Well, notice that this angle will be 90 minus theta, correct? Okay, now notice that this angle and this angle, they are vertically opposite angle. So this angle will also become 90 minus theta, correct? Fine. Okay, So this angle is also 90 minus theta. So which means that this angle will be equal to what? It will be equal to theta. Why? Because one is 90 minus theta and the second one is 90 degree. So the third angle becomes theta. Why? Because sum of interior angles of a triangle is 180 degrees. So 90 minus theta plus 90 plus that angle is equal to 180. So x is equal to theta, correct? Okay. So that is why this angle will be equal to theta, correct? Fine. Okay. Now notice one thing. Of course, I am going lots of detail and basics so that you can understand the concepts from zero, right? So basically, it becomes something like this. If I explain this one, I'm talking about this one. This is your normal, right? And this is your gravitational force which is acting. This will be your theta, correct? Okay. And this is your surface, right? I'm drawing this triangle over here, right? Okay. And this is 90 degree, correct? Now let's break this mg into two components, right? So what do I mean when I say that I have to break its component? Suppose you have a length, this, right? Okay, suppose this is 5 meters, correct? Now you want to check that what component of this length is projected on this axis. Suppose this is x and this is y axis, right? So you have to basically check that what length is projected on x axis and what length is projected on y axis. You have to check that. Okay, so for that you draw a normal over here, a perpendicular. You assume this angle, suppose theta. So this length will be equal to what? Suppose this is equal to y, since it is along the y axis. Let's assume it y. So notice that what is sine theta? Sine theta is basically equal to what? This by this, correct? Right? So it means that y is equal to 5 sine theta, correct? Okay. So it means that its component along y axis is equal to 5 sine theta, and similarly this will become 5 cos theta. Ask me why? Because now you can assume this length as x, then you take cos theta, so you get x upon 5 is equal to cos theta, so you get x is equal to 5 cos theta, correct? Okay, so like this you will solve, right? So similarly, this is a triangle which has this angle as theta. So what will be cos theta? Cos theta will be equal to this length divided by this length, which means that this, suppose this is x component, we are just assuming it. So cos theta is equal to x upon mg, right? Mg is the hypotenuse length, right? So we get x is equal to mg cos theta, correct? Okay. So along this component you are having mg cos theta, correct? Fine. And similarly, along this length, what you will get? You will get mg sin theta. Why? Because you can take sin theta, so sin theta will become this y. So y by mg is equal to sin theta. So we get y is equal to mg sin theta, and since this vector and this vector are parallel to each other, so if this is mg sin theta, then this will also be mg sin theta, correct? So it means that it goes like this, mg sin theta, correct? Okay. Now notice that there will be a normal force which will act on the body, perpendicular, right? Perpendicular to the surface, right? So in that case, the vertical forces will be balanced, right? Why? Because there's no motion in vertical, so that is why there must be no force along that direction, right? If there will force, then of course the block should move upwards, right? Or downwards, whatever be the case, right? So it means that the normal force is getting balanced by mg cos theta, right? But notice that the block is moving downwards, right? So it means that this mg sin theta must produce some kind of acceleration. And what is acceleration given by? Since mass is constant, so F is equal to ma, right? Correct? So mass and mass gets cancelled, so we get acceleration is equal to g sin theta, right? So it means that the acceleration of the block, this m, in this case will be g sin theta, correct? Now this was the case without friction. Now let's assume with friction. Let's see what happens, right? So now let's see this problem with respect to friction also, and the coefficient of friction is given as mu. And in this we are assuming that the coefficient of static friction and kinetic friction are equal, right? It is just an hypothetical case, but for simplicity I'm assuming that, right? So basically, but one thing you should know, that friction is a self-adjusting force, basically static friction. Why? Because suppose if you apply over here some force, suppose 10 Newton, right? Okay. So suppose its mass is equal to 5 kg. So in that case, it will experience a gravitational force of 15 Newton. If you assume acceleration due to gravity as 10 meter per second square, right? So it will also experience a normal force in this case, right? Well, since there is no torque, so it should go like this only, in the direction only, right? So it means that in this case, this is normal, this is Newton, this normal, let me name it as suppose S, right? So S is equal to 50 Newton, correct? Okay. Now notice that suppose the coefficient of friction is equal to 0.5, right? Fine. So hence in this case the friction force will be equal to what? Mu times mg, because over here the normal force is S and S is equal to mg only, so we can write S in place of mu S, we can write as mu mg. So you get 0.5 into 15, so you get as 25 newtons, right? Correct. So now notice that friction should act in this direction, right? This is static friction. Now notice that of course you can't apply 25 Newton force over here, else the object will start moving along the dash of friction, right? So it means that the friction in this case will be equal to F only, right? So it means that this is the maximum value of the friction, of the static friction, right? So it means that till the time the value of the force does not become equal to the maximum value of the friction or the limiting case of friction, till that case the static friction will be a self-adjusting friction, right? Self-adjusting force, I mean, right? Because it will take the values according to values of the force applied on the object, right? Okay, understood? Okay, let me raise this. So now let's take this question. Well, let me just draw it. Yeah, I'm not drawing the surface, but you all know that it is there. If I will draw, then it will take lots of space. But yeah, you should draw it, is compulsory, but right now to explain it I'm not drawing it. Okay, this is theta, right? This is m. Now suppose, of course it is obvious that the object will move downwards only, right? If no force is applied on the object. So this is your mg cos theta, correct? Okay, and this is your normal force, correct? And this is mg sin theta, correct? Okay, and this is your, sorry, and this is your frictional force. Okay, now assume that the object is moving in the downwards direction, right? Okay, so in that case what we have to consider? Well, since the net force is along the mg sin theta component, so it means that the mg sin theta minus the frictional force must be equal to the mass times acceleration, correct? Correct, yeah. And the second thing is that n should be equal to mg cos theta, correct? Fine. And the second thing over here is that over here that frictional force is equal to mu times the normal force. What is the normal force value? It is equal to mg cos theta, right? Just substitute it over here, you will get mg sin theta minus mu mg cosine theta is equal to ma, correct? So from this you get the value of acceleration, that acceleration is equal to g sin theta minus mu g cos theta, or you can say g into sin theta minus mu g, sorry, mu cos theta, right? Okay, so it is a case in which there is no other force applied on the object, just the frictional force and the gravitational force. Now suppose I start applying some force on the object, then what will happen? Well, let's see it. Suppose now I apply a force in this direction, F, right? Okay, so in that case that force will get added in this case, right? F plus mg cos theta, so it will become F plus mg cos theta minus this quantity, rest everything will be same, right? So it will become over here plus f by m plus f by m, correct? Like this, right? Depending upon the direction, right? Of course you can have this force at an angle also, right? It will depend, suppose it is at an angle alpha, right? So in that case you have to break the components of force as f, suppose as this will become f cos alpha and this will become f sin alpha, right? Now in this case there will be just one thing you have to notice, that over here it will become f cos alpha then, right? And over here in friction, basically in the calculation of the normal force, non-normal force will not be equal to this quantity, right? Why? Because now there's another force acting on the object in the vertical direction, right? So it becomes f sine theta plus the normal force will be equal to mg cos theta, right? Sorry, it will be mg sine alpha. So from this you will solve for the value of n, and similarly you will just substitute n over here, right, as mg cos theta minus f sine alpha, and gradually solve it, right? So in this you can be given different values of forces, angle and whatever things, and they can ask that when the value of acceleration will be 0, right? So simply just put a is equal to 0 and you will get the answer, right? Correct? That is how you solve such kind of problems, right? And there are many other things which you can do over here, right? And of course this concept if you apply in the case of a roller, so let's take one more case in this, right? Suppose you have a roller, right? So you must have heard about it, right? But I'm not going to tell that is the pushing or pulling easier or whatever case. I'm not going to tell that, because it actually depends on the size of the object, right? So if I tell this, well, it depends on the direction of the force you are applying on the object, right? So basically if you are applying the force in this direction, right, suppose this angle is alpha, so here it will be mg, correct? Right? So this component will be f cos alpha, and here it will be f sine alpha plus the normal force, right? So it means that f sine alpha plus n, correct? Yeah. So in this case the value of frictional force will be mu times mg minus f sine alpha, correct? So it means that the magnitude of the mg is being decreased by this f sine alpha, right? Now notice that if I reverse the direction of force, instead of pulling it, I push it, right, in this direction only, right? So it means that I'm just applying the force in this direction, right? In this direction, or basically if I extend it, I'm applying the force like this, okay? Basically, this is the direction of force. So in that case, since I reverse the direction of force, so notice that this is alpha. So this will be f sine alpha, right? This will be f sine alpha. But now here, n is equal to mg plus f sine alpha, right? Why? Because this component will come down now, right? Correct? So it means that in that case friction will be mu times mg plus f sine alpha, correct? So it will be much difficult to move the roller in that case. So I won't say that is it pushing easier or pulling easier, because it again depends on the direction of the force you are applying, right? Because suppose if you are applying the force like this, uh, by any means you can, if you are applying the force like this, right, you're still pulling it. But in this case also, this is alpha, the force is again being distributed like this, its component are like this is f cos alpha, sorry, and this is f sine alpha, right? So how can we say that pushing is easier or pulling is easier? It depends on the direction of force actually, right? So notice that if you apply the force in this direction, that is basically for pulling the object, then in that case pulling becomes more tougher as compared to pushing, and over here pulling becomes easier as compared to pushing, right? So it actually depends what you are doing. So that is why I did not say that is pushing easier or pulling easier. It depends upon you, that whatever direction you are applying the force. But in a nutshell, if I say, this is a basic idea which you should know. And there's something more important in this, that is a spring system, which I'm going to tell, right? Suppose you have a system like this, correct? Okay. And suppose a string is like this, sorry, a spring is like this, sorry, not a string. And suppose there's a block over here, right? If you want, we can solve it using friction also. If you want, we can negate friction also. So first of all, let's solve it without friction, then you can add friction also, right? In that, if you all want, I can add friction also, there's no issue in that. So let's evaluate this without friction, right? Okay. So of course here it will be mg sine theta, correct? This angle is theta, right? By now you should be well acquainted with this, because you know now derivation, so you can easily solve such kind of problems, right? Okay. Now this is mg sine theta, right? And suppose that the block is not moving, the acceleration is 0, which means that the net force acting on the object must be 0, right? Since the vertical forces are cancelled out, right? Since there's no force along vertical, right? So it means that mg sine theta must be balanced by the spring force, right? This is a spring constant, this is the elongation in the spring. So x is equal to mg sine theta by the spring constant, correct? So this is the elongation in the spring, and if you want to calculate the energy of the spring, it is half kx square, half k times this expression mg sine theta by k, right, whole square, correct? Now if you apply friction also in this case, then in that case the friction will act in this direction, right? Because the body is tending towards, because the body tries to move in this direction but is not able to move, right? That is why. So mg sine theta minus f and kx acts in that direction minus kx must be equal to 0. So it means that x is equal to mg sine theta. What is f? Now you should be well acquainted with this, mu mg cos theta by k, and you can apply again the same thing, right? You can just balance the forces and solve it. Assume that there is no frictional force in a spring, right? We assume that, okay? So we can use this concept over here. Now we are well acquainted with such kind of system and flat system also. For flat system, you can just substitute theta 0 to get a flat system value, right? Now let's see some pulley problems also. We will not see constrained motion in this case. We're just going to look the case of pulley, and in the case of the pulley which has mass, right? Massless pulley, then the pulley with mass, that is rotation, right? Let me raise this. So suppose this is your pulley, and suppose it is hinged, of course it will be hinged, of course it will fall, right? So suppose you have a pulley. I have not shown the hinge point, but it will be hinged. I did not draw it because it will take lots of space in board, right? So that is why. So suppose this is a pulley, and of course this case is without the mass of pulley. Suppose the mass of the pulley is 0, right? Okay. So the tension will be equally distributed in all the cases, right? Because we are assuming it without friction and a massless pulley, right? So the tension will be like this, T and T. It will be equally distributed in both the directions, right? So it means that this is M1 and this is M2, right? So here it will be acting, suppose M1G force, right? And here it is M2G, correct? Okay. Now notice that suppose the body is moving in this direction, that is this mass, right? So of course this will move like this, correct? Okay. So we need to find the tension and acceleration, right? Of course, many people learn this formula, they wrote learn it, and then when such kind of problems come, they can easily solve it. But if I just change this problem a bit, they will get confused. Suppose I add 2-3 masses more, they will get confused that how do I find the tension in those masses, right? So that is why proof is important for every concept, right? So you should know everything, right, in this, right? Now, physics is not just about rote learning formula, right? Physics is an emotion which you have to understand, and that is the craziness of physics. If you understand it once, you will never forget it, because it expresses everything from atoms, from quarks to complete universe. Just our human brain is not that much capable to understand the completeness of physics. So that is why many times many people just think that physics is a boring subject. No, it is not. You have to just understand it properly with derivations and with every conceptual clarity, with all imaginations. Imagine Einstein made whole relativity through his imaginative power. So just think how important is imagination for physics, right? So if you can just imagine properly, you can be the king of physics, right? So just remember this thing, right? Before doing any problem in physics or understanding or reading any concept of physics, right? Physics is not a subject, it is an emotion, it is a part of life, it is your life, right? So we'll leave this topic for now and let's come back to the topic, right? Okay, so basically you have to balance the forces again in this case. So basically the net force is along the upward direction, right? Means the net acceleration in this case is along the upward direction, in this case it is in the downward direction, right? So it is because the tension is more than m1g in this case, so that is why the body is moving upwards, right? Since the net tension, net force is along upward direction, that is why the body is moving upward, right? So it means that T minus m1g must be equal to m1a, correct? Correct. In this case, m2g is greater than T, so it means that m2, sorry, it will be m1g. m2g minus T is equal to m2a, right? Just add them, you get m2 minus m1 g is equal to m1 plus m2 a, correct? Hence you get a is equal to m2 minus m1 g by m1 plus m2, right? And this is what many people wrote learn, right? Okay, but you don't need to wrote learn now. You know the derivations, right? Okay, now from this you can clearly solve for tension also. Suppose T minus m1 g is m1 times m2 minus m1 by m1 plus m2 into g, correct? Fine. Okay, so you get T is equal to this quantity minus, sorry, plus m1g. So you get T is equal to m1 m2 minus m1 square minus, sorry, plus m1 square plus m2 m1, correct, by m1 plus m2 into g, correct? Just see the calculations if you agree to it, right? So m1 and this gets cancelled, so you get 2 m1 m2 by m1 plus m2 multiplied by g, and that is the value of tension in this case, right? So this was the case without friction and without any mass of the pulley, right? Now let's assume friction and mass of the pulley also, right? So let's see it. Of course, if friction will not be there, then in that case there will be no rotation of the this block also, right? So we have to assume friction in this case, right? So that this pulley can rotate, right? Then only it will be rotation, right? So friction is important for rotation in this case, right? Of course, for max cases, friction is really important for rotation, right? For example, if you are just leaving a block like this, it goes like this. So if you want it to rotate and come down, so you must have a friction in this case, right? Then only it can happen, else it will just slip down, right? So that is why in questions, whenever friction is there, it is said without slipping, right? Which means that there's friction. Without slipping means friction. You just imagine, suppose if there's lots of water and you are walking and you just fall down, so you say that you slipped from the surface, right? Which means that there's no friction in that case, and you, that is why you slipped, right? So now assume that you're walking on a rough surface, right? And in that case you say that I'm not slipping, and that is called no slipping condition, without slipping. That friction is present in that case, right? Understanding or not, right? That is the basic case. Okay, so let's see it with rotation also. So max things will remain same, but notice that since we have involved friction in this case, so now the tension will change, will differ. Why? Because due to friction and inertia of this pulley, this the value of tension will vary in this case, right? It is due to the friction, right? Nothing else. Now notice that, let me remove this. Suppose this is like this, okay, and this is a normal to this string, and this is perpendicular, right? Okay, this is the radius, right? Correct. And since it is rotating, that's why it will produce torque also, right? So it means that the value of torque will be equal to, suppose, T2 minus T1, that is the net force multiplied by the perpendicular distance, that is R. Correct? Correct or not? Yeah. Okay. So this is the first case, and the second case, I mean the second equation, it will again be m1g, sorry, T1 minus T2, sorry, T1 minus m1g, it will be equal to m1a, correct? And for this it will be equal to m2g minus m1, sorry, m2g minus t is equal to T2 is equal to m2a, correct? So you have this equation and this equation, right? Now you know one formula, that tau is equal to I alpha, right? Correct? Okay. So I, and what can we write for alpha? Alpha is basically, now notice that it is without slipping. So it means that acceleration is equal to R alpha, correct? Fine, fine or not, right? That is why you can write tau as I a by R, which is equal to T2 minus T1 multiplied by R, right? So this is our next equation. Of course, you know how to find the moment of inertia of the object, and acceleration which you need to find, radius will be given to you, T2 and T1 you have to find. So how many variables you have? T2, T1, two variables, R and all this quantity will be given. A is your variable. So how many equations you have? 1, 2, 3, three equations you have. And M2 will be given to you, G you know, and T2 we already counted, T1 we already counted, M1 will be given to you. So we have three variables and three equations which you can easily solve, right? So this is how, if you solve this system of equation, you will get the results, right? So I won't say you to learn the formula, just remember the concept that how the forces will be balanced. Then you can just put the values and solve for these equations. It is very simple, right? You can solve it easily, right? So let's take another problem which I told, this one, right? In which rotation is involved, right? So let's take this one also, and then let's end this lecture. Now this is your system, this is an inclined surface, and this is a body, right, which is rotating also while making the motion. So why it is rotating? Why? Because this friction, it is happening without slipping, right? That is why. So it means that, let's zoom it. This is your body. Sorry, this is like very much, it's something like this. Okay, my drawing is not good, so okay. So this is how it is going. Now notice that since it is happening without slipping, so it means that at this point the net velocity must be equal to 0, right? Do you agree or not? Why? Because this point has to be at 0 velocity so that this point can move down, right? Because if this point won't have 0 velocity, then this body won't rotate, it will just slip down. Why? Because if the velocity of this point and this point are same, then why will it rotate? Since its velocity in both the axes, suppose it has a velocity v in this direction and a velocity v in this direction, so they both will cancel each other, right? So why will it rotate, right? That is the concept. There will be no rotation in that case, right? So basically over here we will have v is equal to r omega, right? Omega is the angular velocity or the angular speed basically, right, in this case. And yeah, so now notice this is your perpendicular distance, right? Correct. And since the body is moving downwards in this direction, right, so the friction will act like this. Correct? Correct or not? Yeah. Okay. Of course the direction is changing continuously, but we are not taking that into account, right? So don't worry about that right now. We're just dealing with a simple case right now. Okay. So basically this is the basic idea. This is your radius. So in this case also tau is equal to fr, correct? Fine. Okay. And We have mg, suppose its mass is m and it is going a over here. This is your friction. Mg sine theta minus friction is equal to ma. This is also correct, right? And the second relation or the third relation, we have this: v is equal to r omega. This is equal to I a by r. I alpha, we already told that v is equal to r omega, so we can say dv by dt is equal to r d omega by dt. What is d omega by dt? It is equal to r alpha. And what is dv by dt? It is equal to acceleration, correct? So a is equal to r alpha, so from that we can say I alpha is equal to I a by r, right? Okay, so you have this relation and you have this relation and you have this relation, right? So basically this one. So from this you can easily say that what you have to find, you have to find frictional force and acceleration. You can easily find from this. Let's solve for suppose, first of all let's solve for friction. So we get F is equal to IA by r square, correct? So we get mg sine theta minus IA by r square is equal to ma, correct? So we get mg sine theta is equal to a times I by r square m plus m, which implies that a is equal to mg sine theta by m plus I by r square, correct? Fine, understanding or not? Okay, fine. Similarly, you just substitute value of a in any of these formulae to get the value of friction, right? So you will get some value of friction also. That is your homework to find, because I have already solved for a. You can easily solve for f. And now kinetic energy will be equal to half mv square, that is a translational kinetic energy, plus half I omega square, right? So this is the total kinetic energy of this body. This is due to the rotation and this is due to the translatory motion or translational motion, right? So with this we come to an end to this lecture. So with this we come to an end to this lecture. If you enjoyed this video, then please do like, share, subscribe my channel, and we support this video. Bye bye, take care, and all the best.